Welcome to Brain Vision.
Hi everyone, so what we have is glass bottles that are being washed and rinsed in a bath that's at 50 degrees C. The bottles enter at a rate of 450 bottles per minute from an ambient temperature equal to 20 degrees Celsius. The average mass of each bottle is 150 grams, and when these bottles are removed from the bath, there's actually 0.2 grams of water that's removed per bottle when the bottle is removed. So to fill this bath back up, makeup water enters at a temperature of 15 degrees C, and what we're asked to solve for is the rate at which water and heat must be supplied so we remain at steady state conditions. So the first thing we're going to do is just go ahead and write down our assumptions. We're going to assume that we're operating at steady state conditions, so conditions are not changing with time. And we're going to assume that any heat that is lost from the outer surface of the bath is negligible. And we're also going to assume that water is incompressible. So any changes in rho are equal to 0. So what we're going to do next is look at the properties of water and glass that were given to us. So the specific heat of water we can look up in a table, and we'll find that Cp of water is equal to 4.18 kilojoules per kilogram degree Celsius. And we can also look up in the table that the Cp for glass is equal to 0.8 kilojoules per kilogram degree Celsius. So next what we can do is we can find the mass flow rate of glass, and we can do this by using the information that's given to us in the problem. So we can say that the mass flow rate of glass is equal to the mass of each bottle times the flow rate of the bottle. So we'll just call that FL. And we know that the mass of each bottle is 150 grams. So that's going to be 0.15 kg per bottle times we have 450 bottles per minute. That's going to be 450 bottles per 60 seconds. And what that gives us is a total m dot of glass equal to 1.125 kilograms per second. Next, what we can do is we can do an energy balance and say that the total energy coming in minus the total energy leaving is equal to the total change in energy of the system. But since we're assuming that things are operating at steady state, the total change in energy of the system will be 0. Therefore, we can say that E dot in is equal to E dot out. Now we can break this up into its constituents and say that E dot in is the heat that we're supplying plus m dot h1 is equal to the total enthalpy that leaves m dot h2. Now we can solve for Q in and set this equal to the Q dot a bottle and say that this is equal to m dot h2 minus h1. Now we can use the definition of enthalpy and specific heat to say that this is going to be equal to m dot Cp T2 minus T1. And this is m dot, or Cp of water. So what we can do is actually go ahead directly solve for the Q dot bottle in terms of the heat that's removed by the bottles, and say that Q dot bottle is equal to the m dot bottle times the Cp of glass times the delta T of the glass. So by plugging in for these quantities, we'll see that the Q dot of the bottle is equal to 27 kilowatts because we're given the delta T, that's equal to 35 degrees, and Cp and m dot we already have from the previous step. So what we can do now is go ahead and calculate the m dot of the water that's coming out. So we can say that m dot water out is equal to the flow rate of the bottle, so we know it's 450 bottles per minute. And we also know that there's 0.002 grams that's removed per bottle, so that's going to be equal to 0.0002 grams per bottle. And that gives us an m dot of water removed equal to 0.0015 kilograms per second. So this mass that's leaving is actually made up by the water that's coming in at 15 degrees C. So we can actually calculate the total heat removed by the water that sticks to the bottle by saying that Q water removed is equal to the m dot of the water removed or out times Cp times delta T. And that's Cp of the water. So by plugging in for these components, we know what m dot W of water coming out, because that's 0.0015 kilograms per second. We know the Cp of the water, and we know delta T to be 50 minus 15 degrees C. So this gives us the total Q out by the removed water to be equal to 0.2195 kilowatts. Therefore, the total heat that's removed is equal to Q dot, that's total, is equal to the Q dot from the glass removed plus the Q dot from the water removed. So by adding the 0.2195 kilowatts with the 27 kilowatts, that gives us a total heat transfer equal to 27.22 kilowatts, and that's the heat that must be supplied. And the m dot water that we're also asked to solve for was this 0.0015 kilograms per second.